Okay, this is Unit 8, Lesson 3, Day 3 homework. This comes from pages 590 through 601 of your Course 3 textbook of the Core Plus Mathematics textbook series. And so I'm going to take a look at question number 6 to begin today. And question number 6 says, determine which of the following mathematical statements are true and explain how you know this without the use of technology. So the first statement that we're asked about is about the cosine of pi over 3 being equivalent to 1/2. Now right away when I see this kind of problem, I'm thinking of this half as being a ratio from a special triangle. And I know that 1/2 is referencing the small side to the hypotenuse of a 30, 60, 90 right triangle, or if I'm thinking in terms of radians, a pi over 6, pi over 3, pi over 2 right triangle. So I'm going to draw that out just for a moment here. The smallest angle will be the opposite the smallest side. The smallest angle is 30 degrees, which is pi over 6 in radians. And then the largest angle is 60 degrees, or 90 degrees, I should say, is opposite the hypotenuse. 90 degrees is also pi over 2. I'll kind of mark that over here on the side. And then the medium angle, 60 degrees here, would be pi over 3 in radians. And then the smallest side, of course, is 1. And the longest side we'll put as double that. And it makes this short side then 1 square root of 3, or square roots of 3. So that's one of the special triangles we're referencing. So cosine of pi over 3. If I begin over here at pi over 3 is this angle here. Cosine, if I think about SOHCAHTOA, I'm going to write out SOHCAHTOA in case you've forgotten it. That is the ratio of side lengths for a right triangle. And if I reference the cosine 1, cosine of my angle should be the adjacent side over the hypotenuse. So pi over 3, the adjacent side is 1, hypotenuse is 2. So it is true that cosine of pi over 3 is 1/2. True. And you can see that reference over there on the triangle. Part B suggests that the arc cosine, or inverse cosine, of the square root of 2 over 2 is equivalent to pi over 4. Now I'm seeing square root of 2 over 2, I'm seeing pi over 4. It references the unit circle or another special right triangle. In particular, this right triangle, though, is a 45, 45, 90 right triangle, or in radians, pi over 4, and pi over 2. And in this one, we actually have the hypotenuse being 1, and then each of these sides is the square root of 2 over 2. Okay? So the cosine of pi over 4 would lead to square root of 2 over 2. Therefore, the inverse cosine of square root of 2 over 2, that ratio of adjacent side to hypotenuse, or this being the adjacent side, hypotenuse, would have to be referencing a pi over 4 or a 45 degree angle. So this too is true. And we can see that ratio right there. Part C says, let's take a look at the inverse cosine of square root of 3 over 2 equals pi over 6. I'm actually reference again back up here in the 30, 60, 90 degree right triangle. Inverse cosine of square root of 3 over 2. Square root of 3 would be this side, 2 would be the hypotenuse. So the ratio of square root of 3 over 2 in reference to cosine would have to be adjacent to the pi over 6 angle. So here I see the pi over 6 come out. That means that the cosine of pi over 6 would equal square root of 3 over 2, or as written, the inverse cosine of square root of 3 over 2 leads back to pi over 6 for the angle measure. So this too is a true statement. So as you can see, these are very closely referenced to the special right triangles, 30, 60, 90, or 45, 45, 90, or their equivalent radian values as seen here. So that ends question number 6.